So let's look at a quadratic now in our first attempt to solve a quadratic. And we're going to use the completing the square method because, first of all, if we try to factor this, which is always our first attempt, we should always see if it factors cleanly. But I can't find any factors of 4 that add up to a -6. So this one doesn't factor in the set of numbers that we're comfortable with. And in fact, most quadratics don't factor cleanly. Their roots are a little bit more irrational at times, or just numbers that just don't line up nicely. But good that we have a tool to solve it. So let's solve this. So let me just gently, we're going to cross it off because factoring doesn't work. Our method is, in order to solve it, we want to help set it up by learning to complete the square. And to complete the square, it's always easiest to set up just the x terms on one side and the constants on the other. And to do that, I'm going to subtract 4 from both sides. So now my goal is I'm looking for this magic number right there. And that magic number represents what? That's right. It represents that corner of the square that we need to figure out what its dimensions are to make the entire square work together. And we did that by taking the middle coefficient, which is a -6, divide that by 2, and then squaring it. -6 divided by 2 is a 3. -3 squared is a 9. So 9 represents the area of that one little corner piece, which turns this side now into a perfect square. Turns it into an x minus a 3 squared. On the right side, I also have to add this magic number. I just can't add it to one side and leave it alone, because whatever you add to one side of an equation, you have to add to the other side. And I'm not changing the equation, because we remember our skills of algebra says the equation doesn't change by adding the same amounts to both sides. And that's what we're doing. So then on the right side, I have my original -4 plus a 9, which gives me a 5. In this position now, I think I can see the end in sight. I'm going to use our square root property, which means take the square to both sides. When I do that on the right side, remember I'm going to get a plus or minus √5. Solving for x, I have x, add 3 to both sides, I have 3 plus or minus √5. So the solutions of this particular quadratic, meaning what are the values of x to make this a true statement? One value was x equals 3 plus √5, and the other one is x equals 3 minus √5. Using that method is a lot easier because I don't think I would have found these as its factors with that particular equation. So, hope that helps. We'll look at a couple more examples coming on up.